think it's pointed to correctly.
Yeah, it's warming up.
Okay, while this thing gets started up, I'll just give you a little quick background here. Typically, I'm the guy who's sitting way in the back, who's extremely quiet. So this is my first time in front of the audience here. But I'll be speaking at the jQuery conference coming up next week. And so this is an extremely raw format right now. And what I wanted to do was present this to you guys and hopefully get some feedback.
Is it fuzzy?
First feedback, okay.
Is there an adjustment on this thing?
Is it that or the
No,
rest?
it's a projector. It's okay. I got it.
Projection, okay.
Okay, good.
Is that better? Okay.
Is it sharp enough?
We're all good? Okay, cool. And so this will be my first time speaking in the conference as well. So like I said, I just want to get some feedback from you guys, preferably not during the presentation, but afterwards just come to me and say, hey Jason, I fell asleep at this part, you rambled on, it was extremely boring. You should fill some gaps here, so just some feedback. Try to be a little polite about it, I don't want to cry afterwards. So we'll get going. Okay, so my talk's going to be about unit testing in a client-server AMD codebase. Are you guys familiar with what AMD is? Anybody, pretty much? It's, okay, so AMD is just a way to manage your modules. It's a way to define dependencies and include them into your codebase JavaScript. You know, typically in Node, you're running CommonJS on the server. And this is going to talk about running AMD on the server and on the client so that you can run code like in both environments without having to switch your dependency management system. Then it falls back on how do you test this once you have this running in both environments. So that's what my talk will be about. But before we get into that, I just want to ask a couple people, how many people actually unit test their JavaScript code? By show of hands. Okay, so what is that, like 30, 40%? Okay, not too many. Okay, so how many people enjoy unit testing? We have a couple insane people on the front row. I actually never unit tested any of my code until I went to Walmart over a year ago, and I first started unit testing it, and I hated it, and I still hate unit testing my code. But some things I found out were, you know, the importance of it was that I got immediate feedback on it. I found errors before my code hit dev, stage, production, all these different environments, and I also found errors in like some flaws in my API. I thought all these years I've been writing this brilliant, amazing code. And then I go to write one unit test and everything bombs out. And I'm just wondering how many errors I have out in production over 15 years or so of writing code. It's bad. So I quickly realized that, and then it caught regressions later on in this life cycle. So I really just, I hate it. It's like a necessary evil, but I found the benefits to it.
Oh, ignorance is bliss.
I'm sorry?
Ignorance is bliss.
Yes, it was. I enjoyed that for many of years until I had to start writing it. So, like I said, it was my first time writing it, and so I'd be in meetings at Walmart, and they'd be like, oh, okay, we're going to use, this test harness, and I'd be, typing away on my computer, test harness, what the hell is that? Okay, got it, and keep going through this on a daily basis, trying to figure out what all these terminologies are. Oh, here's our test runner, we're using BDD, just all this stuff. There's like this overwhelming amount of information that I had to pick up at the time. And so, I finally got over that hump, and then I started to take a look at like we were actually running there. And at some point in time in the process, every single one of these libraries or frameworks has been in our code base. And the reason for this is because we're a remote office. The main office is up in San Bruno, up in Northern California. And so we didn't have any processes in place. We didn't have any frameworks, codes, anything decided on into place. And so we kept iterating over these different libraries, plugging gaps here, ripping this out, didn't work. The code was changing. And then so we ended up with a extremely large grunt configuration file, a ridiculous lifecycle that nobody could follow, and a bunch of boilerplate code in every single spec that we wrote. So it became just like this huge, massive amount of glue code, and just a nightmare to maintain. It was just, it was just horrible. I hated it, and so that made me, love unit testing code even less. So I had this grudge on my shoulder. I hated it, and then, we were writing this framework, and it was supposed to, power Walmart.com, but things kind of changed a little bit. Priorities shifted. And then we changed the framework a little bit. And so originally what we started out with is it's all Node. So we have client-server code running, but there's this huge divide between the client and the server code base. And then, we had unit tests for the server, different test runner for that, different test runner for the client. And then what we ended up finding is that we wanted to share code. And we were running CommonJS on the server, like I said, AMD on the client. And what we ended up doing was creating a new framework that runs on the client and the server. So I can write my models, my collections, my controllers, my views, all this good stuff. I write it once. And then the framework optimizes it, abstracts away all the differences between the environments so that I don't really have to care, where it's running. As a developer, I can just write my application, write my code, and go on my merry way, and the framework handles everything for me. But then we wrote this framework, and we were like, okay, shit, all right, how do we unit test this? Last time it was a nightmare, it was horrible, it was just awful, like I said. And then so we were like, okay, we have to unit test this, we don't want to make the same mistakes we made last time. And then so he said, well, obviously the first thing we want to do is we want to unify the unit testing framework. I want to have to write a specification, and I only want to have to write it one time. I really don't want to care what the test runner is, whether the test runner is a test runner for the client or whether it's for the server. I want to abstract away all that nastiness for me so I can just focus on writing my spec and my unit test. And then so what we came up with is a set of requirements. And the first one is that we wanted it to be agnostic, not in the sense that, religious agnostic, but agnostic in the sense of the environment, of where it doesn't really care where the spec is running, client, server, we don't care. We write it, it wires everything together, and we're good to go. And then the second major requirement we have were the mocks. With AMD, we wanted to say, okay, I'm writing a spec to test module A, and module A has a dependency on module B. I want to go ahead and mock that, and I want to just put that in a directory, have a little config that points to where my mocks are, and my unit tests run. If I say I'm mocking that, it just pulls it in, resolves all the paths, does everything for me, and I'm done. The third requirement was we wanted to kind of resolve and automate everything, meaning that I wanted to take my application files and I wanted to have my configuration for require.js. I wanted to load that. I wanted to say, okay, I have all these relative paths, I have IDs for these paths, and when they run, regardless of the environment, I want these paths automatically resolved for me so I don't have to do this again. I don't have to write out boilerplate code. And so we wanted that, and then again, we just wanted to be able to write a JavaScript spec. And then when we run our client tests, we wanted to take some templates that would load this specification and wrap it in an HTML file that we could load in any browser, including like Phantom.js when we're automating stuff. So that was huge for us. And then the last thing we wanted was code coverage. We wanted to be able to have it automatically instrument the code for us, run this, and generate LCOVE reports. Does everybody familiar with LCOVE, what that is, the formatting for it? Well, it's a common format that we run, I forget what it is we run internally, some big Java stupid app, Sonar. Okay, we run Sonar. Everybody knows what, yeah, Sonar's awesome, yeah. Okay, but it consumes LCOVE. So we wanted to be able to consume that file easily, and then on top of that, we also wanted a simple HTML version of the coverage report that we could run locally and take a look at the differences and see, where we need to fill our code coverage gaps in. So that I could do that locally, commit it up, LCOVE would get up, and then everybody up top would be happy because they'd say, oh, look at this amazing code coverage. You got really high numbers, great. So we kind of wanted that illusion that we were doing something good, I guess. And then next, so what we came up with is Grunt Castle. And Grunt Castle is a Grunt plugin, and we'll get into what Grunt is a little bit later for those of you who aren't familiar with what Grunt is. But basically, all these kind of discrepancies, all these, the wiring and all the stuff that I talked about before, test runners, all these things, I didn't want to have to worry about that. I wanted to have to write just a simple JavaScript object configuration, do a simple command line, type it, and have it just execute my test and walk away, and I'm good to go. And so that's kind of what this does. It abstracts all our stuff for us, so we don't have to worry about it again. And like I was saying before, we can just focus on writing our unit test. So there's basically three main pieces to it. And then one is like a testing lifecycle that does all that wiring for you. The second lifecycle will be coverage, which is basically the same as testing. We'll take a look at that. And then the third one is actually taking a look at the specs you're writing and that spec lifecycle when these test runners are loading that spec, what it looks like inside the specification. So, all right, so the first part of the testing lifecycle, I come into the command line, I say grunt castle, it executes, it kicks off, reads my configuration file, and again, we'll take a look at the code a little bit later. But the first thing it does, it says, okay, I have these assertion libraries, and for us, we're using, I think, chai, sign on chai, and should. And we want this automatically added to the global path so that in my spec, I don't have to worry about loading these and resolving these and things like that. And then what I wanted to do was take my application file, my application configuration, my require.js application configuration, and I wanted it to resolve all the paths for both environments for me automatically. And the last thing I wanted to do was take this and then configure a version of require.js for me. So again, I don't have to load require.js, I don't have to do any of that. It just reads the configuration file, goes through the setup, and then the next step is that it runs the server test. And then so it resolves those specification paths for me. I've told it where my specs lie. It says, okay, I'm going to take all these specs, add them to the runner, and then I'm going to go ahead and execute all the tests. Okay, and the client is basically the same thing, but there's just one minor difference. The client executes all the tests inside of Phantom.js for you, and so there's some HTML templates that it takes, and it says, okay, I'm going to take these plain JavaScript files that you've written, and I'm going to generate HTML files for you that you can load in any browser, so then I can do like automated cross-browser testing in the future. But when I'm executing this, we're executing Phantom.js, so it's the same process, but except for it resolves these HTML files that have been created. Executes the test, and then that's it, and my client tests have been run. So both server, client, set up, good to go, I'm done. And then the coverage is the next part, like I was talking about. We wanted to have code coverage generated for us automatically. And so all the steps are the same as server, so I'm just going to kind of differentiate just the different things it does. The first thing it does is it instruments the code, and do you guys know what I mean by instrumenting the code or anything like that? So basically it'll take a JavaScript file and say, okay, well, I'm going to give you line numbers for each line number of the code. And so when my application runs, it runs against this instrumented code, so that when the code is executed, it can tell me if I hit that line or not. And that's what's going to tell me, oh, well, my unit test is covering 75% of the actual file. So it instruments that code, and then, so if my application lived in a directory called lib, my configuration would say, well, I want this instrumented code to be written to another directory, say like libcov, and then it's going to take my require.js configuration, and it's going to find all my paths and resolve them to that new directory where my coverage reports are, or where my instrumented code is automatically for me. And then again, the major differences here, I'll just pull these both up, is that instead of sending the output to the console, we create a write stream, and we redirect this out to a file. So the stream is outputted to either the HTML file that I was talking about, so that I can take a look at my code coverage reports locally, or it outputs it to a JSON format, which then we then take and convert to LCOV reports. And so that's done for both the server and the client. The difference between the client is that it reads those HTML files that we created, the specifications. Okay, and then so just quickly, if you look back in here, it's created these files, and then there's a step in here. Sorry, 1 second. We're adding these specifications to the runner, and these are the specifications of my unit test for each module. And then so when these are executing, this is what it looks like inside of each of these individual specifications. The first thing it does at the top of the file is it loads Castle, and Castle is just a wrapper to require.js and to Squire.js, and Squire.js is it's a mocking library to mock dependencies for AMD. And then so it's taken all that configuration, all these paths that's resolved, and it's automatically wired that up for you. And then it loads any other dependencies at the top. So say if your client test, you want to do some DOM manipulation or something like that, or you want to load some different assertion libraries, what it does is it loads those for you. So like you can load jQuery, anything you want to do for that specific unit test or specification, you can load it right there at the top. Second thing it does is it comes through and it says, okay, you want to mock these libraries by ID. These paths have already been resolved for you. And then it's going to add the ability to mock globals, because one of the things we found when we mock globals is that I'll have a specification run. Somebody will say they'll modify this global object. The second specification loads, and then it breaks, or the 10th one loads and it breaks. And so it's hard to kind of find out who it was that broke that global object that's breaking all the other specs. And so you can now mock these global objects very easily. And then what ends up happening is that each time a specification loads, it blows away the old global, so you get a clean copy, so you're not ever corrupting the global object and breaking specs down the line. And the last thing is it's right now it's using Mocha, so it loads that module you defined, then it just runs a specification. Everything from that point forward looks like a normal specification. All right. So we'll take a look at some code now, and then again, who isn't familiar with grunt? Are people familiar with grunt? Or a lot of heads, no, shaking, yes. Okay. Are people familiar with like ant in Java or anything like that? Yeah. Okay, so I mean, you can kind of think of it like at a very high level, like ant is a task runner for Java and it uses XML, but grunt is a task runner for JavaScript and it uses a JavaScript file and your configuration is in a JavaScript object versus that XML file. So, okay, awesome. This is a very large version of Sublime Text 2. Okay, so this is your configuration file. This is your grunt file. So this grunt file lies within this directory right here, this Lazo directory. And Lazo is this new application framework that we wrote. And then so when I'm in this directory, and if I say grunt, you know, some task, what ends up happening is grunt will start in this directory, look for this grunt file.js. If it doesn't find it, it'll keep going up directories until it finds a grunt file. And then it'll try to, you know, resolve that task to that file. But, so here's the configuration that each grunt file has. And in this case, there's Castle, which is the plugin that we wrote. And then so this is the task, this is the target. And you can have multiple targets, but if you only have one target, you don't have to list it. When we execute the command, you'll see that later. It'll automatically resolve to this target. And each target has a set of options. And in this case, we're saying, okay, our mocks reside at this directory, which is relative to where this file is. And so we have a couple mocks here. And this mock is the global object that I was talking about, and so this gets loaded. We want to mock this sometimes and clean up like I was talking about between each test. This is, there's a request library for Node, and then so we use this to kind of, to mock like model calls and collection calls to services and things like that. But those are just a couple examples of some mocks. And then another option is we have to tell it where our specs lie. And then we have to give it a base URL because it kind of does some fancy resolving, and I'll touch on that in a second, but it says, okay, our spec base URL is here and it's in the spec directory. These next three properties, one is saying all of our client specs live here, all of the server specs live here, and all of our common specs live here. And the common specs, when the server tests are run, are merged in with that, and when the client tests run, those are merged in with that. So these will be run in both environments. We'll know if they fail in either environment. The last one is a target for where I was talking about the client HTML specs get written. So those get written there, and if you look here, we'll take a look at one of these in a little bit, but this is where all these specs get generated to for the client test. You can load into any browser. This is the require.js property, and this is typically you have a configuration for your application for require.js, and so this is the exact same thing, and you have the ability to say, well, when I'm running on the server, I want to use this configuration, and when I'm running on the client, I want to use this configuration. So for us, the base URL is this root directory up here, our Lazo directory, and then we're just reading in a paths file, which is this paths.json file, and we'll be taking a look at the context spec, and so all we have to do when we get in there is use this ID. It'll take this and it'll resolve this path for me regardless of what environment I'm in. And then so now we have our configuration for both environments. Some of this stuff is going to be changing, so there's a reporting option right now. And so it does some static analysis. It bundles in Plato so I can take a look at my code and see how maintainable it is, things like this. We'll probably rip out code coverage because it's kind of, the plugin's trying to do too much. We were just trying to abstract all of our stuff, but it's kind of doing too many things right now. So probably should have ran this first. Could have talked about that, where this was going. But,
so is there any plans to open source the Castle?
it's going to be open source, probably this week or next week before the presentation at JQCon. So the first thing that happened here is it executed the server test. And this is all just based on a little simple configuration we had there. And then so I have a failed unit test, which I should fix. You know, this is all Mocha on the server, Mocha on the client. And then it gives me the stack trace for it. And here's where it's writing out those client specs. So it's taking just a standard JavaScript specification, it's generating these HTML templates, and we'll take a look at one of those. And it just runs through all my unit tests. And then so, this is what a specification looks like. And then so everything from here up is kind of the boilerplate code that you want to have, but again, you could probably use some sort of includes here to only have to write this once, some configuration, things like that, but just for simple purposes, it's just kind of fully written out here before. And then so this is Mocha's before each, and I'm saying it's asynchronous because this is kind of the first problem that people run into when testing AMD code is that the test runner usually just loads a bunch of script files, then executes. But AMD by nature is asynchronous, it's asynchronous module definition. So things might not be loaded when the test executes. And so that's usually the first hurdle, even if you don't use this framework or anything like that, that's the first hurdle that people have to get through. So we're loading that castle file, which I told you is that simple wrapper around things. We get a pointer back to it, and then we call this test function. This test function takes an object, and the first one is that module that we want to load and test against. And so I just have to pass this ID for it because it's already resolved all the paths for me. There would be another property here called mocks. So if I wanted to, I could load an array of mocks because context may say, you know, I depend on this file, that file may depend on this file. There could be this huge dependency tree traced down there. And then I could just kind of cherry pick out and say what I want to mock inside of that dependency tree. But in this case, we only care about mocking the global object, Lazo, and we say we want it exported into the global namespace to this, you know, resolve to Lazo, all uppercase, which on Node would be like global Lazo, and then in the browser would be, you know, window Lazo. So all these things happen for you. The callback executes. You now have a pointer to this module right here, and then we set up this variable outside of this closure so that now our unit test down here, for instance, will now have access to that module outside of this closure. Done execute says all asynchronous code is done. It's running, we're good to go. And then from this point forward, we can just write unit test like we would Mocha and anything. And again, this is going to run the client, this is going to run the server. I don't have to worry about anything for me. And for us, we're loading chai right now, like I said, and sign on chai and should. And so I can just say chai expect, and I don't have to worry about loading it. I don't have to worry about anything. It's just there, and I can start working against it. And so these are just some simple tests. The context object is really just inside of Lazo. It's kind of hidden away from the developer, but when a request comes in, an object is created, it follows the lifecycle of that request. Says, you know, I need these models, I need these collections, I'm fetching all this data, I need these views, these templates. And then it's then serialized, it's sent to the client. The client takes that, kind of reinflates it, and then kind of builds out the view for you on the client. So it doesn't feel like push state, so you're just kind of pushing objects back and forth and the client's kind of rendering. But the first page load is actually rendered on the server because of SEO concerns. So it's kind of for public-facing websites so that we can render it on the server, send a chunk of HTML up, then reattach all these views and all these models and things like that. That's kind of outside of this discussion. We'll be open sourcing that sometime this year. I don't know when. It keeps getting pushed back. But so we'll be having that coming out. But in a nutshell, all this really does is kind of handle all the wiring for you and all the resolving for you and all this kind of stuff that was like a huge pain in the ass to maintain. We've just taken 1,000 lines of code and hidden it away and given you like a configuration object that you can work with and wire all this stuff together. So you can just be focused on writing your specifications and unit testing versus wiring up Mocha, Phantom, all these different libraries to try to get this to run right and work well for you in a diverse set of conditions. All right. So given that, our roadmap is just like I was saying before, we want to narrow the plugin's focus. I had written this, because we had all that, just a bunch of hideous code and stuff that I wanted to kind of hide away. And when doing that, I kind of made the plugin more than it should be. And so we want to take the code instrumentation out and just give you a couple reporters that you can work against, and then you can decide how you want to instrument your code and just point this to it. The second thing we want to do is we want to kind of modularize it and define some contracts so that right now everything's running Mocha. So if you've written all your unit tests in Jasmine and you're using Jasmine as your test runner, I'm hoping that we can kind of write something that just has a nice API that you can say, I'm using Jasmine, I'm using Mocha, and then you don't have to worry about it, it'll just be another configuration option. And then the next thing we want to do is we want to make, like I said, we're loading these assertion libraries for you automatically, but these are just the assertion libraries that we wanted to run. You should be able to, as a developer, to say, okay, well, these are the assertion libraries that are like the sensible defaults, but I don't want to use these. I want to load my own assertion libraries, or I want jQuery always loaded on the client, so things like that. So we want to make that pluggable. And the last and most embarrassing part of this is that I have no unit test for this. So that's how much I like writing unit tests, as I said. So we need unit tests. And there's, this hasn't been open source yet, so this is in a private repo right now. But we're going to open source, so I have to get some more information out there on the README and things like that, and one more legal hurdle to clear. Thank you. Yes, I have to clear that, and then we're going to open source this, get this out there, and then hopefully we're looking at people to make some contributions, because this is also my first grunt plugin I've written. I've never written a grunt plugin before, but I didn't want to have to keep maintaining that just nastiness. It was just too much to take to write unit tests. But anyway, that's pretty much it. Any questions?
Can you talk a little bit more about taking client tests and server tests and mixing them together? Like what?
Well, okay, so